everyone, and welcome back to Remathable, where math starts making sense. Today's video is part of a special playlist designed specifically for pre-IGCSE or pre-O-level students. Even if you're currently doing your O-levels or IGCSE, I strongly recommend watching this video at least once. It's a great opportunity to brush up on your foundational concepts or clear up any confusions before moving on to more technical problems. In this video, we will be exploring the basics of prime and composite numbers and then building on that understanding to explain prime factorization in a simple and structured way. But before we get started, make sure you have a notebook dedicated entirely to math, or even better, call it your Remathable notebook. Keep organized notes as we go along because they'll really come in handy when it's time to prepare for your exams. So let's begin. We'll start by understanding what prime and composite numbers are. So what are composite numbers? Two types of numbers that differ based on the number of factors they have. Okay, so what are factors? Factor is basically a number that divides another number evenly. So when you divide it by a number and there's no remainder, then we call that divider a factor of the number. Okay, so what are the factors of 6? Factors of a number, as already explained, are numbers that divide the original number evenly. So there's no remainder. So the factors of 6 are 1, 2, 3, and 6, right? So 6 divided by 1 is 6, 6 divided by 2 is 3, 6 divided by 3 is 2, and then 6 divided by 6 is 1, right? No remainders. The number 6 is evenly divided by these numbers. So these are the factors of 6. So a composite number has more than 2 factors. So any number that has more than 2 factors is called a composite number. Examples include 4 and 21. So 4 can be divided by 1, 2, and 4. We have 3 factors, so 4 is a composite number. Similarly, 21 can be divided by 1, 3, 7, and 21. It has 4 factors, and therefore 21 can also be categorized as a composite number. Now, what is the other category? The other type of numbers are prime numbers. What are prime numbers? A prime number has exactly 2 factors. Oh, sorry for the typo. Okay, so the spelling here need a little change. So a prime number has exactly 2 factors, 1 and itself. Okay, so what are the examples of prime numbers? So let's take 2 as an example. We can divide 2 evenly by 1 and 2. That's it. There's no other number that divides 2 perfectly. So it has exactly 2 factors. Therefore, 2 can be categorized as a prime number. Now let's have a look at 5. 1 and 5. Again, 2 factors only. So 5 is also a prime number. Can you think of any other numbers? 3. 3 can only be divided by 1 and 3. 7. 7 can only be divided by 1 and 7. So all the numbers which have exactly 2 factors can be categorized as prime numbers. Okay, so I hope the distinction between composite and prime numbers is clear. Any number which has more than 2 factors is a composite number. Any number that has exactly 2 factors is a prime number. Okay, now a question for you to think about. Is 0 a composite number or a prime number? I hope you guys got it correct. 0 is neither a composite number nor a prime number. Why? Because it has infinite number of factors. And to be a composite number, it must have a finite set of factors. The 0 is not a composite number. Okay, so I hope this is clear. 0 is neither composite nor prime. Okay, what about 1? Is 1 a composite number or a prime number? Well, since 1 has only one factor, which is 1 itself, right? So, according to the definitions of the composite and prime numbers, 1 is neither composite nor prime. Because prime numbers have exactly two factors, while composite numbers have more than two factors. Whereas 1 has only one factor. So 0 and 1 are two digits which are neither prime nor composite. Okay, now prime numbers from the first 200 digits. I have put them up on the slides. You can screenshot them, keep them for revision. Now, a question that a lot of students ask me is that whether they should memorize them or not. I would say at least try to. Having the smaller prime numbers at your fingertips really helps when solving higher level factorization or divisibility questions later on. Okay, so give it your best shot. Okay. Now we'll dive into what prime factorization is and how to do it using simple methods. Okay. Basically, the prime factorization of a number is all the prime factors that multiply together to make that number. Okay, so I'm going to give you very basic examples and then I'm going to get on with slightly more difficult level questions. Okay, so for example, let's look at the prime factorization of 49. So any prime numbers which multiply to make 49. The only prime numbers that multiply together to make 49 are 7 into 7. Okay, so 49 is equals to 7 into 7. This is the prime factorization of 49. Okay, we write prime factorization as a multiplication sentence like this. I will also get into index notation in a minute. Okay, what is the prime factorization of the number 10? Think about it. It's very simple. It's 2 into 5. 2 is a prime number and 5 is a prime number as well, right? Okay, let me get into more. This was very basic level explanation. Let's dive into slightly more detail. So as you already know, whole numbers can be grouped by the number of factors they have. One group is known as prime numbers, and the other is known as composite numbers. Prime numbers have exactly two different factors. Prime numbers have exactly two different factors, whereas composite numbers have more than two. Okay, so this is the distinction between the two numbers. Okay, now these are small tips and tricks. They will help you if you keep them in mind. Okay, so let's try this. Tips. Okay, so if you have an even number, you know that every even number is divided by 2, right? Then there's a divisibility test for 3. It can be very helpful to check whether a big number is divisible by 3 or not, right? A number is divisible by 3 if and only if the sum of the digits is divisible by 3, right? What does that mean? So for example, we have 387. So what are the digits? 3, 8, and 7. You're going to add them together, and the sum of the three digits is 18. And since 18 is divisible by 3, we know that 387 will also be divided by 3. Okay, so these are small tricks. I think they will help you in prime factorization and even otherwise in maths. So keep them in mind. The third one is trial division. To understand this, you need to know what square and cube root is. So basically the concept of square root and cube root. I will get into that in another video, but hoping and assuming that you know what a square root is. Very quickly, square root of 4 is 2. What does that mean? So 2 multiplied by 2 is 4, right? So square of 2 is 4. and under root of 4 is 2. So if you have a prime number, a big prime number, and you need to check, if you have a number and big number that you need to check whether it is prime number or a composite number. So what you can do is you can apply this trial division method. So a number is prime if it is not divisible by all the prime numbers less than or equal to the square root of the number. Okay, so let's not get confused. Let me give you an example of this. Okay, so 997. Let's find the square root of 997. You can use a calculator. So from the calculator, we find that the square root of 997 is 31.6. Correct to one decimal place. Okay, so I've rounded off the number to one decimal place. Okay, so let's list all the prime numbers less than or equal to 31, right? So what are we going to do? We're going to list all the prime numbers less than or equal to the square root of the number. So what is the square root of the number in this case? It's 31.6. Okay, so first let's jot down all the square numbers which are less than or equal to 31. So the prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, and 31. Okay, so all the prime numbers less than the square root of this, which is 31, are these. Okay, now what you're going to do is you're going to check if 997 is divisible by these factors or not. Okay, so you can try that. And then pause the video, try dividing 997 by all the factors, and then I'm going to tell you what the answer is. Since 997 is not divisible, any of these prime numbers we can safely state that 997 is a prime number. Okay, so rather than trying to, see and check with larger numbers to see if 997 is divisible by them or not, the trick is to find the square root of the number and then list all the prime factors below, less than or equal to that number. And if any of the prime numbers divide that number evenly, then it is not a prime number. But if they're not divisible by the listed prime factors, prime numbers, then that number is also a prime number. Okay? I hope this is not very confusing. And this is not actually a concept, it is just a trick or a tip to help you figure out whether a number is a prime number or not. Okay, now before we move on to actual prime factorization, I also want you to understand what index notation is. Okay, so if we have this multiplication statement, okay, so 5 is being multiplied how many times? 1, 2, 3, 4, 5, 6. So you can write this as 5 raised to the power 6. Okay, so this is the index notation basically. Okay, 5 raised to the power 6 is called the index notation of 5 into 5 into 5 into 5 into 5 into 5. Okay, this 5 is known as the base, 6 is known as the exponent or index. Okay, and how do you read this? 5 to the power of 6, not 4. 5 to the power of 6, or 5 raised to the power of 6. Okay, basically index notation helps or ensures that we do not have to write a whole string of numbers and multiplication signs, or if there's so many zeros. So it basically helps you write a multiplication sentence simply, concisely, and there are less chances of error as well. Okay, now finally moving on to prime factorization. As already touched upon, the process of expressing a number as a product of factors is called prime factorization. Okay, there is a fundamental theorem of arithmetic that you do not need to memorize, but basically that states that every whole number greater than 1 is either a prime number or a number that can be expressed as a unique product of its prime factors. Okay, so basically either it's a prime number itself or you can express that number as a product of its prime factors. So basically prime factorization. So either, again, very simply, either the number is a prime number or you can express the number in terms of prime numbers, product of prime numbers. Okay. 18 is a very simple example. So 2 into 3 is 6, 6 into 3 is 18. So 2, 3, 3 are prime numbers, and we've expressed 18 as a product of its prime. Had I asked you to write this in index notation, it would have been 2 into 3 raised to the power 2. Okay, same thing. Okay, so do not confuse prime factorization with factors. They're two different things. So let's, for example, what was the prime factors of 18? It was 2 into 3 into 3. Right. What about the factors of 18? Okay, so we're talking about 18 here. Can you list the factors of 18? Numbers which divide 18 completely. So it is, the factors are 1, 2, 3, not 4, not 5, 6, not 7, not 8, 9. And then since the half of 18 is 9, after that it's going to 18. So see, these are the prime factors and these are the factors of 18. Okay, so they're closely related, but I hope you're absolutely clear about the distinction between the two. Okay, now how do we go about finding prime factors? So let's do an example. Okay, so there are two methods. One is the tree method that I'm not going to touch upon, but if you're comfortable doing that, it's perfect. Just go ahead with it. If you want me to explain how to go about solving prime factorization with using the tree method, just drop in a comment and I will get back to you. The method that we are going to employ here is the basic ladder method. Okay, so let's imagine we need to find the prime factorization of 60. Okay, we are going to begin with the smallest prime factor, which is what? Which is 2. So let's begin with 2. I hope everybody knows how to carry out short division. So 2 3s are 6 and 30. Again, if you have an even number, I would say that the safest bet is 2. So always divide an even number by 2. Okay, so 30 divided by 2 is 15. Then we're going to use 3, 5, 5 and 1. We divide until we obtain 1. Okay, so we need to have 1 in at the end. So divide until we obtain 1. Okay, so where are the prime factors? So these are the prime factors. If you multiply them together, you're going to get 60. So 5 into 3 is 15, 15 into 2 is 30, 30 into 2 is 60, right? So therefore, 60 is equals to 2 into 2 into 3 into 5. This is the prime factorization of 60. And let's express this in index notation. It would be 2 raised to the power 2 into 3 into 5. So that is how prime factorization is done. I am going, my I hope the concept is clear. If not, please rewatch the video. And then on the next slide, I have 5 questions, 5 practice questions, and I want you to try them on your own first and then match your answers with mine. Once you're done, drop the number of correct answers in the comments. I would love to see how you did. And as always, if you have any questions or confusions related to this topic, just leave them in the comments below and I'll do my best to get back to you as soon as I can. If this video helped you, please share it with your friends or family who might benefit from it. These are the questions. Pause the video here, solve them, and then once you've solved them, I'm going to share the answers with you. Check them and let me know how you did. So these are the answers. Wishing you all the very best. Stay curious, stay confident, and keep it remathable.